Good morning, scholars. This is Mr. Plum here with you to make another exciting video about physics. Today we are going to be talking about motion because motion is relative. Now, what does that mean? Well, before we jump into that, let's take a look at this first slide that you see here. What you see here is a rocket ship getting ready to launch the Mars Perseverance rover. It's the next rover we're sending to Mars. I know we already have a few up there, but this one is going to be the most advanced rover, and it actually launched on July 30th successfully, and it's currently on its way to Mars. It should be there in February, and the cool thing about this rover is that it was named by a high school student. So last year, NASA opened up a competition for anyone in the public to be able to name the next Mars rover, and this young lady won the competition, and she named it Perseverance. Pretty cool name, I think. The other cool thing, and we'll talk more about her later, the other cool thing about this rover is that it's going to be carrying a helicopter with it. You're saying, well, what's that so unusual about that? We fly helicopters all the time. Yeah, here on Earth, we have never flown a helicopter on another planet. And so you have to have an atmosphere for that. And so if you remember from watching the movie The Martian, Mars does have a small atmosphere, and it has a very thin atmosphere that will hopefully allow this helicopter to fly. So it should fly, and it's going to take off, and it's going to have some cameras. It's basically going to be like a drone, um, and it'll fly, and it'll take pictures and have some sensors attached to it to find out some information about Mars. Now, you might ask, why are we sending another rover to Mars? Well, there's still so much we don't know about Mars before we go there. And we're currently scheduled to fly to Mars in 2030. Want to take a ride? One of you could theoretically be an astronaut going to Mars. So anyway, but also we are going back to the moon in 2024. So all pretty cool stuff that I'm really excited about space travel and exploration in our wonderful solar system we live in. So let's talk about motion. How is it relative? So let's say you're sitting on the porch and you see a kid ride by on a skateboard. Who's moving, you or the kid on the skateboard? From your perspective, it appears that the kid is moving and you're just sitting still. The reality is you're both moving, since the Earth is both rotating on its axis and revolving around the sun at a speed of about 67,000 miles per hour. You, however, are blissfully unaware of just how fast we're moving at all times. This is what we mean by relative motion. Okay, so in motion, there's the concepts of speed, velocity, and acceleration. Speed, and this is the terms from physics. Speed equals distance over time, or d over t, and velocity is speed in one given direction. Acceleration is a change in velocity over an interval of time. So you might want to pick notes on that, record that. Now within speed itself, there are a couple different types of speed. So you see there a speedometer. And when you look at the speedometer, of course, that car is not moving because it's just sitting there at zero. But let's say you're driving down the freeway with your parents, and some of you might actually be driving now. And so you're getting ready to pass the semi in front of you. You want to change lanes and you want to speed up. So you jump up to say 70, 75 miles an hour. At that moment, whatever you see on the speedometer is your instantaneous speed. Okay? So remember, instantaneous speed right at that moment, also known as an impulse. Okay? And then you have average speed. And average speed, like it says, is a total distance covered divided by the time. So let's see, there's an exit, 12 miles. The next exit is 12 miles, and you really got to go, man. You've been holding it. You drink that 64-ounce Big Gulp from 7-Eleven, and now you got to go. So, but you got to wait 12 miles. So let's say it takes you 4 minutes to get to that exit. So you just simply take the total distance, 12 divided by 4, and that's 3. So you say you went 3 miles per minute. Now, what would that be in miles per hour? Well, you'd have to convert the minutes. You'd have to go back and you'd have to say 60 divided by for and figured out what the mileage is. But basically, average speed is just total distance covered divided by the time. And that last little thing there, the more they burn, the better they learn. I threw that in there because it's going to give you guys some important perspective. Studies have shown that if you want to improve your grades, well, if you just want to do better in anything, exercise and staying physically active will help you to get better grades. So keep up exercising. Okay, then we talk about velocity. You see here we've got the Space Shuttle Discovery, which was the last of the space shuttles to fly, and that is its last flight in 2011. And then on the left you have one of my favorite roller coasters. It's known as the Accelerator, and it's at Knott's Berry Farm in Southern California. If you don't know what Knott's Berry Farm is, it's about 10 minutes from Disneyland, and personally it's one of my favorites. I prefer Knott's Berry Farm to Disneyland simply because Disneyland is more geared for little children under 10, and it's got all those. It's pretty cool. Disneyland is cool, don't get me wrong, but I would rather personally go to Knott's Berry Farm. It's got many more cool rides than Disneyland, and also the price is different. So like right now, you can go to Knott's Berry Farm for one day. It's $89, and for one day at Disneyland, the cheapest price ticket you can get is $104. So, but let's talk about these two vehicles. The bonus question is, which one of these vehicles has velocity? So let's think about velocity. Velocity is in speed in one direction. So you look there, and it looks like probably the Discovery Space Shuttle is moving in one direction, straight up. Okay, so that is velocity, and as long as it moves in one direction, it has constant velocity. Okay, then on the left, you've got that roller coaster. Now, what's really cool about the Accelerator roller coaster, and those of you who love roller coasters, right on, I love them, but usually you go up a really steep hill first before you start going fast and go down. Now, this ride is different. And if you look really closely underneath the purple cars, you'll see that the track has these little silver things and stuff, and there's Accelerator is powered by a linear induction magnetic motor, which means that you don't have to go up a hill. And you can see there's got headrests, and before you can go, there's one of those people who walk around, the attendants, and they make sure your seat belt's fastened, and the little thing that comes over your hair is all fastened and secure, and they tell you to put your head back against the headrest. And the operator will not push the button for the ride to start until everyone has their head on the headrest. Simply being, the minute he pushes that button, it's going to go from 0 to 80 miles per hour in 4 seconds, and that is pretty cool. So your head will slam back if you don't have your head against the headrest. And if you ever go on this ride, please don't try putting your head forward just to say, oh, Mr. Plum said I couldn't do it, because you're going to injure yourself. I'm serious, man. You're going to get some whiplash, and you're going to have a sore neck. So and they won't run the ride unless you have your head all the way back. But so as long as the Accelerator, that roller coaster there on the left, goes in a straight line, then it has velocity. The minute it reaches the end of the track there, and you see how it goes up and flips over and curves and goes around and does some other stuff, at that point it no longer has velocity. But what? It's moving forward. But you're not moving in one direction because you're changing direction. As soon as you change direction when you're moving in a vehicle, you no longer have velocity. You can still have acceleration, but you're not having velocity, because velocity is speed in one direction. Which brings us to acceleration. So what people often do is they get acceleration and velocity and speed. They get these three things all confused. And they are very similar, but they are different. Acceleration is a change in velocity over an interval in time. So here we got a couple of really fast cars. On the top one, you've got a Top Fuel dragster. Those suckers burn alcohol, and that thing will go from 0 to say 160 miles an hour in about 5 seconds. So it's faster than that roller coaster. Have I ever been in one? No. Would I go in one? Heck yeah, you betcha I would do that in a heartbeat. Um, on the bottom one, that's a McLaren F1. That's a McLaren race car, not a race car, I'm sorry, McLaren production car. That is the fastest, as far as I can tell, best that I know, according to what I looked up. That's the fastest production car. Obviously, it would be illegal to drive it at its top speed because I think that thing has a top speed of like 220 miles an hour. But still, both of those vehicles go very, very fast. And they accelerate, a change in velocity over an interval in time. Now, here's the thing. Another concept about acceleration that you may or may not have thought about. So you see there on the left that what you're looking at there, the picture underneath where it says acceleration, what you're looking at there is a disc brake system. And that's a high performance disc brake system, you can see. And the blue things are, they grab that disc. That disc is the rotor. The rotor is attached to the wheel. So this is how your cars slow down. And the disc brake, so when you step on the brake, there's hydraulic fluid that moves and it goes to that master cylinder, which is the silver thing right there by the tires, and those two blue disc brake pads squeeze the rotor like this. They squeeze it. And so you're applying pressure to the rotor and you're causing a car to slow down. Now that is also acceleration, but you don't normally think about that as acceleration. Because look again, look at the definition. Acceleration is a change in velocity over an interval of time. So you're in the top car, the top fuel dragster, those cars don't have brakes. If you've ever watched those things, the only way they slow down is with that parachute pops out behind them, and that's what slows them down. And because they don't need the extra weight of a brake system. However, the McLaren and all other types of race cars, they have brakes, and they have a brake system like what you see on the left there. And so in order to slow down, you're also experiencing acceleration. Kind of counterintuitive. We don't normally think about it that way because we're thinking acceleration, yeah, go baby. But acceleration is also slowing down. The disc brake grabs that rotor, causes you to slow down, and you are actually experiencing acceleration as you slow down. Now, that brings us to the concept of free fall. So a scientist sits under an apple tree enjoying the beauty of the nature. A sudden gust comes along, causes the branches to sway. As he sits there, the scientist sees an apple fall from the tree. So the question here, we just learned about acceleration. Does the apple accelerate while it is falling? Yes, it does. It's accelerating because gravity is pulling at it at a constant rate, but it will continue to go faster and faster depending upon the distance. So right there, that's what, about 10 feet from the top of the apple tree down to the ground. There's not much room for acceleration. So later on, the scientist takes that apple and he goes up in a hot air balloon and he decides to drop the apple from high in the sky. Say he's up at about, most hot air balloons go up, they don't go up higher, much higher than about 10,000 feet because the air gets too thin. And you can go higher than that, but most of the ones, they don't, because you have to take breathing oxygen mask with you because the air gets too thin. So the scientist drops the apple from the balloon, the hot air balloon, and it will continue to accelerate. And but in our atmosphere, there's a time and a place where any object that is dropped in our atmosphere will accelerate to a certain speed and not accelerate anymore. That is called terminal velocity. And what happens with terminal velocity is the air friction causes it to slow down. On the right there, this is SpaceX. So if you've been following the news at all this summer, SpaceX back in May launched a spacecraft to go to the International Space Station with 2 American astronauts on it. And what was so cool about this launch is the first time since the space shuttle, I showed you earlier, in 2011, that was the last time that an American-made spacecraft took astronauts to space, to the International Space Station. So SpaceX, Elon Musk, I'm sure you guys have heard of him, he made this company, and They launched a rocket on a Falcon heavy lift rocket on back in May, and it took 2 astronauts up to the International Space Station. Just about a little over a week ago, they came home, and that's their craft, that's their capsule, the Dragon capsule, coming back as it's getting ready to land in the ocean. So the parachutes help slow it down. Now, as it enters the atmosphere, it's going to slow down, and you can see the black on the bottom. That's the heat shield, because as it goes through the atmosphere, it's experiencing a lot of, it doesn't want to burn up on re-entry. But like I was explaining, if you're a free faller and you're skydiving, you jump out of an airplane, you're going to be flowing down, going down, 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 down fast, but you're going to reach a point where in the atmosphere you can't go any faster because of air resistance, and that is approximately about 127 miles per hour. But the reason that they have to put those parachutes on there is that even at 127 miles an hour, you hit water, it's pretty dang hard. So they have to use the parachutes to slow down the capsule before it hits the water. Free fall is just what it says. Now, what would happen if you had no air resistance? So this is an experiment, one of the experiments that Galileo did when he was trying to prove that the Earth was not the center of the universe. And it was later repeated by Sir Isaac Newton and a few other scientists. But you see there in the picture on the right, you've got a glass cylinder with a feather and a coin. And the right, it's in a vacuum. So you drop the feather and the coin in the air. It has normal air, just like the air that you breathe. And yes, the coin's going to hit the ground first. Now this is like before we talked about Galileo did an experiment with a heavy cannonball and a small iron ball, dropped them, and they both hit the ground at the same time. However, with a feather, because a feather has air resistance and it's designed to catch the air and make it float, in air, the feather and the coin dropped, the coin will always hit the ground first. However, if you're in a vacuum with no air resistance, then you drop the coin and the feather at the same time. Even though the coin has more mass, the feather and the coin will hit the bottom at the same time because of the constant pull of acceleration, which is a constant. Now there on the left you see an astronaut, and this was Apollo 15. That's not an actual photograph. If you can tell, you can look at that. That's a pretty good computer rendering. But they did an experiment where they took a hammer and they took a feather, and they wanted to see if Galileo was right. And they dropped the hammer and the feather on the surface of the moon because the moon has no atmosphere. However, it does have gravity. And if it didn't have gravity, the astronaut wouldn't still be standing there, and the rover and his landing craft would fly away. So they dropped the hammer. He dropped the hammer and the feather at the same time, and yes, they hit the ground at the same time on the moon. So, ladies and gentlemen, that is motion. And there'll be more stuff to come about motion. So just remember, keep your eye on the goal and have fun with science.